Like many scale modelers, it's unusual for me to complete a kit straight out of the box, preferring to add some extra details or an off the instructions colour scheme to make that particular model unique. And my Unimog fire truck is no exception, with the addition of a fully detailed rear interior, which, with no aftermarket parts available for my specific kit, I've designed myself and 3D printed in resin, which is a new departure for me. So in this film I'll be sharing how I made it, for anyone who fancies giving something similar a go. My kit is a Unimog U1300L Feuerlösch, if I'm saying that correctly, from Ace Models, a Ukrainian manufacturer that mostly specialises in military vehicles, although with some civvy exceptions, like mine. At 1/72nd scale, the finished model isn't going to be that big, and some of the parts are tiny, so the build promises to be challenging, even before we get to my extra bits. But rather than focusing on the construction, it'll be my additional details that we'll be covering in this film. Starting with the scan of a QR code, which was the inspiration of the whole project in the first place. This took me to Ace Models' website, and amongst the other reference photos, I found this, a shot of the truck with the shutters open, and immediately I knew it was the interior I wanted to reproduce for my finished model. And for that I'd need to do some research, as the single photo just doesn't have enough information to recreate what's going on inside. Fortunately, we have the internet, and in particular websites selling old trucks, a goldmine of detailed reference photos of every conceivable part from multiple angles, perfect for my needs, although playing havoc with my internet cookies, which are now convinced I'm in the market for a second-hand fire truck, rather than wanting to model a high-pressure pump. But they'll soon work out I have neither the space nor the money for anything other than a 1/72nd scale one. From the photos I've designed this, using a free CAD program called Tinkercad, an assembly of blocks, cylinders and spheres, approximately matching the real thing. As I don't have any technical drawings, let alone a fancy scanner, all this is done by eye, with key measurements taken from the model, very gradually built up into the finished design, which is available to download from my website. So I won't go through the whole thing here, just a taster of how I went about it, starting with some key measurements from the kit itself, not just so the interior will fit, but also to scale the various things visible through the shutters in my reference photos. I'm starting with some simple blocks, one for the floor, matching the measurements I made from the kit, which can be typed into the dialog box. Then I've got an assortment of rectangular shapes for what I think are the main structural elements, or bits that aren't really there, the ones in red, that I'll be using to get the scale of other elements right, cross-referencing with the size of the openings on the photos. Then we can get down to some of the details, and for this I've got my photos up on the screen, so I can refer to the individual bits, like this equipment caddy on the shelf inside the side shutter. For this I've got a long rectangular block, onto the top of which I'm adding a wedge, lifting it with the black arrow so it's level, and then holding down the Alt key I can lift a duplicate of the block, reducing its size by 1/4 mm all round, typing new values into the dimensions or dragging the side handles, whichever you prefer. And then we want to turn this from a solid into a hole by clicking the shaded button. This is now a negative space that we can lower into the box to make it hollow by selecting and grouping our 3 objects, the box, the wedge and the hole, which knocks out from the other 2, making a new object for our equipment caddy, which we can further refine as required. Now onto the 2 lamps beside it, once again starting with a simple block. Entirely self-taught, I've been playing with Tinkercad for about 2 years now, ever since I got my first 3D printer, and I'm getting increasingly audacious with my designs. But essentially the elements I'm using are still the same. As you've seen, you can achieve a lot with a block and a triangle, and we've also got cylinders in our basic shapes, which can be turned into long rods or flat discs, depending on what we need them for. But it's important to remember that curves in particular are going to be subject to the limitations of the type of printer we're using, particularly when horizontal, where layer thickness becomes an issue, especially on a filament printer. But I've decided to be bold and test the capabilities of my new resin printer and see how it gets on with the lenses of my torches and the little handles I've added to the tops, made from 2 simple cylinders. And even though I know that the colours aren't going to print, made a nice silver grey, not only to make the CAD look good, but also to keep track of objects, either as individuals or groups, so when we come to copy them or duplicate, holding down the Alt key, we don't leave any bits behind. Then with a final check against our reference, we can go on to the next bit. I'll be coming back to elements of the CAD for the pump later on, but let's get on and do some printing, so we can try out our snazzy resin printer on a standalone part of the interior, one of the dry powder extinguishers, which will give us a chance to work out what's going on with something small before embarking on the more complex stuff. This is the red spherical item in the back of the truck, which originally I thought was some sort of compressor, and I've also recreated this in Tinkercad. Once again, the elements are quite straightforward, grouped together to a single object, and by ungrouping we can select each one. At the heart is a red sphere, taken directly from the Objects menu and scaled to the size we want. Then for the frame we've got simple rectangular blocks. Cylinders might have been more accurate, but the square profile will do for the scale we're working at, and hopefully will print more reliably. My hoses are made from torus shapes, duplicated and looped randomly on the front of the frame, where a couple of rectangular blocks stand in for the hose clips. Then, just like the real thing, we've got some cross members and a couple of cylinders for the valve on top, all of which we need to export as an STL, and it's that you can find on my website, along with the other files. Direct link in the description. Now we need to turn that into something the printer can use, by slicing the 3D shape into individual layers. I'm quite used to doing this for filament prints, but for resin I'm at the bottom of a steep learning curve, using some unfamiliar software, and new ways of supporting the print, which is taking quite a lot of getting my head round. So this is more a case of showing what I did, rather than a guide to how to do it. You'll find many more informative videos out there for this and other slicing software. But among the things I have learnt is that it's not always best to print the object straight on, and it helps to angle it before adding the auto-generated supports. Then with the settings for my printer and the resin I'm using, I can export the sliced file as a .goo, which is suitable for my printer. As it exports, we get a glimpse of what's going on, which is a light pattern for each layer that essentially solidifies the liquid resin only where we want it, building up our 3D object, one slice after the other. Printing with resin is a brand new adventure for me, and I've got some new kit, an Elegoo Mars 4, which I bought as a package with a wash and cure station for processing after printing. You can do without this bit, but I decided to get them both together right from the start, and chose water-washable resin to make my introduction to the process as easy as possible, without too many noxious chemicals. The Mars 4 is very much at the budget end of the Elegoo range, but even then perfect for what I want to use it for. And having done the initial setup, we can plug in the USB stick, scroll through to our file, and simply hit the start button. No laborious warm-up like the filament printer, just the hum of the print bed lowering with a couple of bleeps when it reaches the bottom. Then after 2 more bleeps, we just leave it to it, as it gives each layer a burst of light. Under the cover there's really nothing to see during printing, and after 1¼ hours, our print is ready, stuck to the underneath of the print bed, the whole process being upside down. And having drained off as much of the surplus resin as possible, we can gently pop off our model, the tip of a scalpel blade sufficient to lever it off the bed. Now we need to wash it, and being so small I've made a little basket for it, so it doesn't just drop through to the bottom of our washer, where we're going to rinse off the rest of the surplus resin. As the technology develops, water-washable resins are now pretty good, and I've gone for this right from the start, avoiding the need for isopropyl alcohol, making the whole process less smelly. But it's still by no means benign, so still worth taking precautions like wearing gloves, although that does make handling more difficult, and I've chosen to go without. Then, setting the unit to wash mode and programming in a couple of minutes, we can hit the start button, spinning the rotor at the bottom of the bucket, giving our model a good wash. Of course you could just do this in a tub, but very importantly, don't just rinse your model under the tap. We really don't need any more microplastics in our water system, and don't pour the washing water straight down the drain without filtering it first. Our print is now clean, but the resin not entirely cured, and we'll need another burst of ultraviolet light to harden it properly. But before that, I want to remove at least some of the framework of support, whilst it's still a bit pliable. For this I've got some angled cutters, a scalpel with a brand new blade, and some fine pointy tweezers for getting into those hard to reach places. In resin printing, the supports have a slightly different function to those in a filament print, which are literally there to support overhangs. Ours also have to do the job of holding things onto the bottom of the plate as the model develops upside down, and prevent isolated elements detaching and floating away into the resin, so there's quite a lot more of them, making removal a rather laborious task, made even more complicated by the scale we're working at. Some of the elements finer than the supports themselves, so we have to be very careful what we cut, gradually nibbling away at the framework, so we can get our cutters right inside and cleanly cut away the supports, without damaging any of our details, which even though it's still pliable, are easy to snap. So you have to use your judgment as to which ones to snip and which ones to cut, and also how far you want to take it, before going on to cure. In retrospect, I could have taken more, if not all of the supports away at this stage, but I decided to leave enough to give it a base on the curing station, which is the same unit as our washer, converted with the addition of a turntable, in place of our washing bucket. And with the press of a button to change the mode, we can pop on our print, cover with the protective lid, and just like with the washing, set a time of around about 2 minutes, long enough to harden the resin under the UV lights, the turntable ensuring equal exposure all the way around. I suspect that larger models might need a little longer, but for this, 2 minutes was about right, long enough to harden without going brittle. Then off with the cover, and now the resin's cured, we can happily handle the model without gloves, although exposure on such a small thing was always going to be limited. Now we can get rid of the rest of the support, which after curing is somewhat tougher, but then so are our details, so they're less likely to bend, and we can get right in, close to the back of the hoses, and trim bits off the frame, removing any remnants where the tips of supports attached to the model. But it is still brittle, and I did manage to break part of the frame, but no worse than snapping something coming off the sprue, and I was able to glue it back together. While all that CAD and 3D printing's been going on, I've been cracking on with the construction of the kit itself, completing most of the chassis and about 90% of the cab, all done exactly as per the instructions. But now we come to the back, and for which we're going to need to do some modifications, each of the side panels coming as a single piece, so we're going to need to cut out our shutters, both from one side and the one on the back. All the parts for the fire truck variation of the kit are on one sprue, and I'm going to do my cutting there in situ with a lot more to hold on to. Fortunately, the plastic is relatively soft, and my scalpel is sharp enough to cut through it, using multiple shallow strokes, following the moulding along the side of the shutter, being especially careful with the strip on the left-hand side. And when we're through all the way round, we can separate the side panel from the sprue, ready for cleaning up, my cutting having left a bit of a burr on the inside, but otherwise a pretty clean straight cut, both down the sides and along the top, where we'll be refitting the bottom edge of the shutter in the open position, so we can also retrieve that from the sprue. As well as the shutter itself, this also has the sill at the side of the floor, so that'll need removing too, so it's just the bottom of the shutter with its handle. We can do all that a bit later on, so let's put that to one side. For the other side of the truck, I decided to leave the shutters closed, making the most of the red colour scheme, obviously saving a bit of work on the interior itself, that side seeming a little less interesting. So the panel just needs a bit of a clean-up, and leaving it whole will help line everything up when it comes to assembly, which just leaves the back shutter, the one over the pump, cut out in the same way as the side. Again, a little bit of burr left behind, but otherwise a good clean cut, with just a small amount of clean-up required, mostly on the sprue attachments. Then, with the floor and all four sides prepared, it's assembly time, just making sure we know which way round everything goes before committing to glue, starting with the two sides I haven't adapted, as I know they'll fit perfectly, ensuring the back of the truck is square, before adding the other two. You'll notice for now, the main part of my interior is nowhere to be seen. That's going to drop into the finished shell, having made an allowance for the slightly tapering sides, the measurements of which I want to check before finally printing, so I want this part to be completed first. When the other two sides are dry, I can check the fit for the rear and the side panel, making sure I know which surfaces need to be glued, the inside of the edges and the outside of the floor, leaving a gap for our missing shutter. Then the back can be stuck in place, carefully lining up so the tops and bottoms are even, and the corner is crisp, so no filling will be required. Finally, the side wall, a bead of glue along the two ends, and the side of the floor, just up to where the opening will be. We still need to make a sill for that, so it doesn't matter if we go a little bit too far, but a daub of glue on the inside of the corner will ensure we've got far enough. Then it's on with the panel, making sure the back's straight and the flimsy front edge stuck firmly to the side of the front, making any alterations so the tops and the bottoms at either end are lined up with the other sides before leaving to dry. Now it's time to fit the shutters themselves, having sliced a small section from the bit we took out before. We actually need to trim both top and bottom, the bottom bit being stuck to the side of the floor to make the sill. Then a section of the remaining shutter can be glued to the inside of the top, making sure the backs are level so the front of the shutter is straight and inset by the correct amount. Once it's dry, we can clean out any of those flaky bits and tidy up that bottom edge. Then it's the same procedure for the back shutter, gluing and carefully guiding into the hole, making sure we've got it the right way up with the handle at the bottom, and once again level at the back, so our attention is drawn to the detailed interior and not distracted by a wonky shutter. We'll get back to my interior very soon, I promise. But one last thing to do with the exterior, and that's to give it a coat of paint. I've already sprayed the inside silver, so with that masked off, it's on with some gloss red, gradually building up the layers of paint with an even application, using my airbrush. Building up to a top coat, where we want to overlap the wet layers of gloss to achieve an even shiny surface, which is best left to dry horizontally to avoid any drips. At the same time, I can also do the roof, making sure I get the paint into the railings, again building up the layers, so we've got even coverage and sheen. This isn't actually that easy to achieve, and my technique is far from perfect, but the more glossing I do, the better I get at it, and the finished thing is pretty good, I think. While all of that dries, it's back to Tinkercad, and that pump, where I just want to share a couple of aspects of the design. Once again, sharing the screen with my reference photo, building up a bunch of cylinders for the parts of the pump, some of them straight, some angled. And the more photos we've got, the better we can work out what's going on, adding elements piece by piece, frequently duplicates of each other, until we've got something that really starts to resemble the real thing. While the pipework looks complicated, actually quite a lot of it is fairly straightforward, a mixture of cylinders and grouped objects making up the curved sections. A torus with 3 negative blocks, grouped together to make a quarter donut, with the same diameter tube as our cylinders. And like a lot of things, we only need to make one, rotating a duplicate for other bends in the pipe run. Rather more complicated are the valves, but even so, they're still a combination of cylinders and blocks, design made easier by assembling them away from the main section. Getting that spoke wheel to print is almost certainly over-optimistic, particularly at an angle, but I've been surprised so far with what can be done, and it will be interesting to see how that comes out. I can always replace them with some simple discs. So now it's time to review what we've got so far, and do some test printing. We'll almost certainly need to make some changes, and there'll be extra details we want to add, as well as refining the print itself. So following the great Blue Peter tradition, here are some I did earlier. My first print was remarkably good, even the thin floor printed okay, but it did chip whilst removing the supports. Obviously at this stage I hadn't completed the inner frame, and there's more to do with the pump, but overall a good start. My next test print was mixed, the water tank and frame now looking good, as does the pump, with the added details. Sure enough, those spoked wheels didn't work at all, so they're now just discs. But my big problem is the base, which is curling up at the ends. I'd thought that making the floor thicker would improve the rigidity, so it's obviously back to the drawing board on that. But there are lots of things that have come out well, even the tiny handles on some of the pipework, printing much better than expected. So here's my final design. I've gone back to the thin floor, but only under the back section, separating off the front bulkhead, which will print on its own, with a gap for the powder extinguisher sitting on the floor of the kit itself. At the same time, I've added some details to the bulkhead, including a pipe that crosses to the rear section, and with that part printed, it's time to trim the supports, to see how well that came out. Once again, I'm doing this before curing, when the resin is still relatively soft. Having washed and dried the print, removing any unexposed resin, so I'm pretty sure it's okay to handle without gloves. Just like with the extinguisher, I'm doing this gradually, making sure it's just the supports I'm cutting, nibbling them away, and tidying up close to the surface. Once again, I have managed to crack one of the thin bits. Nothing a bit of glue won't sort out, but the pipe and the rest look great. So with a little bit of clean-up after curing, we can get on with painting. I think one of the hardest parts of making this video was knowing what to leave out, either during filming or editing, and I'm afraid painting got the short end of the stick. I'd thought about dividing up the model into more easily paintable bits, but eventually decided to go for the whole thing as one. An overall coat of dark cream for the tank, masked off to airbrush the cream of the framework, itself covered to spray silver, which I'm finishing off by hand, getting a fine brush into the hard-to-reach places on the pump. Picking out some of the details like the valves, with a brassy metallic, waiting patiently between coats. Painting is really bringing out the best parts of my print, but also revealing some of the dodgier bits, particularly on some of the flat surfaces, where support removal hasn't been as clean as it could have been. But I'll undoubtedly get better at setting up the prints in future projects, in particular the placement of supports, so they're easier to remove without leaving any evidence. For me, resin printing is a game changer, particularly when it comes to adding extra details to enhance an already excellent kit. And I've noticed a growing number of companies providing aftermarket parts, like fully detailed cockpits or undercarriage sets, for popular kits, all 3D printed in resin, but I don't think you can beat making your own, especially for something a bit more niche, and I hope I've shown how achievable that is. How, with not very much experience and some relatively inexpensive kit, you can quite quickly rustle up something of your own, making a totally unique version of an already unusual model, which we now need to finish off. So with the last bits of the interior painted, we can put it to one side to dry thoroughly and prepare for final assembly. In the meantime, I've just about finished off the underside of the rear body, adding the mudguards and the jerry cans on one side. I've also done a bit more detailing on the chassis, and now it's time to unite the two. Rather than superglue, I'm using a slower drying epoxy applied to the two body mounts. This will give me a bit more time to get the body in the right position, and lining up the mounts in amongst whatever else is going on is a little bit tricky, so we don't want it sticking to the wrong thing. Here you can see just how much detail Ace models have packed into a small kit, the downside being it's really quite delicate, so we need to handle with care while we straighten up the sides, applying gentle pressure to get the base level and then leaving to dry. When fully set, we can test fit the interior, which of course I've done many times during development, but it's good to see the painted thing in position, and now it's finished we can glue it in place, for which this time I am using superglue applied to the underside of the resin, which I've sanded to ensure it's perfectly flat. Then, having removed any excess glue, we can stick it in place, ensuring it's square and central, as the base is slightly narrower than that of the kit, so it fits through the top. Then, with a bit of gentle pressure, hold down long enough for the glue to set. Now for the front bulkhead, with an initial test fit, mostly to check we don't need to trim that pipe now that the main interior is stuck in place. But all good so we can get the glue out, with a couple of blobs on the back, keeping it away from the edges, then carefully manoeuvring into place. That pipe a convenient handle to hold on to with the tweezers, while lowering into position, before pushing the face against the front wall, once more making sure it's central. As is so often the way, solving one problem actually improves the whole thing, and by printing the bulkhead separately, the floor at the front is much better, a completely clear space ready for our powder extinguisher, which will eventually be painted up and glued inside. We've also got the rest of the kit to finish, with wing mirrors and the rest of the cab details to be added, ladder for the back, and of course the decals. But for now it feels like we've reached a milestone, and for the first time, with the roof on, we can see our interior properly. A pretty good recreation of the original, all effectively from scratch. But there's one last feature missing, the slide-out generator, which I've also recreated in Tinkercad, once again using simple shapes, and printed on the Mars 4. I'd already incorporated the inner rails on the main section, so it's just a case of gluing the ones on the generator to those. But needless to say, at that scale, not the easiest of tasks. But eventually I got it on and got it square, protruding nicely from the side of the truck, how it would be when deployed in real life for a real emergency. Then, with a little bit of glue, just enough to hold the roof in place, we can seal in the interior, finishing off our Unimog fire truck with fully detailed interior, all designed and printed myself. What we need now is a forest fire diorama, but you'll have to wait for another video for that.